In this video, we are going to look at exponential functions and their properties. What are the properties of an exponential function? Here's an investigation to help us explore these properties. Given the exponential function represented by the equation y equals 2 to the exponent x, determine its properties. Now, let's start by making the sketch to represent this graph. Use the table of values to help you as you create the sketch for the function y equal 2 to the exponent x. To do that, start by creating a table. 2 columns. The first column x, the second column y. We're going to start with the random x value of -2. So 2 to the exponent -2 would be 1 over 4. Now, let's use the random value for x as -1. So 2 to the exponent -1 would be 1/2. Next we'll do 0. 2 to the exponent 0 is 1. Next random value, 1. 2 to the exponent 1 is 2. Let's try x as 2. 2 to the exponent 2 is 4. 3. 2 to the exponent 3 is 8. Now we're going to plot these points on an xy Cartesian plane. Our graph paper, the y-axis, the x-axis. Let's plot the values for our labels. And now we're ready to begin. So at -2 and 1/4, we're going to put a dot. At -1 and 1/2, a dot. At 0 and 1, a dot. At 1 and 2, a dot. At 2 and 4, a dot. And at 3 and 8, a dot. We're going to add the label y equals 2x to the top of the graph. Now our table of values, and what we'll do in this step now is we'll connect the dots, and you will see that our graph starts off slowly increasing and then rapidly increasing as it continues. The next property, property number 2, is this relation y equal 2x a function? Does the relation represent a function? Here's our graph. We are going to use what's called the vertical line test. Use a ruler, draw a vertical line anywhere on the graph. Move the vertical line left or right. The vertical line only passes through the graph at one point. That means that it passes the vertical line test, which means the relation y equals 2x represents a function. Number 3, how can this exponential function be written in function notation? What does that mean? Well, we've already written the equation in the form y equals 2 to the exponent x. In function notation, it will be written as f bracket x bracket, which we say f at x equals 2 to the exponent x. Now, property number 4. What are the domain and range for this function? Well, the domain is all the values that can be used for the x value in the equation. Since x can be any real number, the domain of this function is written as the set of x such that x is an element of the real numbers. This is written in what's called set builder notation. You read the set of x such that x is an element of the real numbers. What is the range? The range is all the values that can be used for the y values. There are no values of x which will produce a 0 value for y or a negative value for y. So we write the range, the set of y, such that y is greater than 0, and x can be any real number. So it's an element of the real numbers. Again, written in set builder notation. And read, the set of y such that y is greater than 0 and y is an element of the real numbers. What are the x and y intercepts? The x-intercept is the point on the x-axis where the graph crosses the x-axis. But since the graph does not cross the x-axis, there is no x-intercept. What about a y-intercept? The y-intercept is the point on the y-axis where the graph crosses the y-axis. And if we look closely, the y-intercept is equal to 1. Property number 6. What are the intervals of increase and decrease? As you move from left to right, the value of y is always increasing. For this particular function, it's always increasing. There is no interval of decrease. Find any asymptotes. What is an asymptote? An asymptote is a straight line that a curve approaches but never reaches. In this example, the curve is approaching the x-axis, but it will never touch the x-axis. So we say that the asymptote is the x-axis. The equation is y equal to 0. Time to build your skills.